In this video, let us see the last part of embedded system chapter, that is communication interface. Here we are going to discuss UART, parallel interface, universal serial bus, that is USB, Wi-Fi and GPRS concepts. Let us see what is a communication interface first. Communication interface is an essential process for communicating between the two various subsystems in an embedded system. So embedded system will be consisting of many components on board, or the embedded system will be connected to some other device in an external world. For the communication purpose, we require an interface or a set of rules, we say, that will be called as protocol we need to follow. So there are different communication interface we are going to discuss here. There are two major communication interfaces are required. One is device or board level communication interface, where the communication channel which interconnects the various components within the embedded system or embedded product. We can say that will be an onboard level communication interface. And one more thing is an external communication interface. Here, this level communication responsible for the data transfer between the embedded system and other devices or the modules. It can be either wired media or wireless. These two are the major two categories we can say in a communication interface. What are all the examples for these? Let us see. The device or onboard communication interfaces are something like I2C, SPI, UART, one wire and parallel bus interface. These are the examples for onboard communication. And external communication interfaces are, there are two types again. One is wireless communication interface, another one is wired communication interface, where Bluetooth, infrared, wireless LAN, that is Wi-Fi, radio frequency waves, that is RF and GPRS. These are wireless communication interfaces. To communicate two devices wirelessly, we are going to use these. And wired communication, we will be having RS-232C or RS-422, RS-458, or generally we are going to use USB nowadays and also Ethernet and the parallel ports. These are the things we are going to use when we are connect two devices with a wired connection. UART. UART is an universal asynchronous receiver transmitter. Here we need to understand UART is a universal communication interface where it is asynchronous. Means here the things are not going to communicate with the clock signal is concerned. Means if there are two devices like this, these two wants to communicate, and these two communications, transmitter and receiver ends, will not be synchronized with a clock signal is concerned. Common clock signal will not be assigned to these two. That is what asynchronous means. And this is an serial data communication protocol. Means if a system A, this is system A and this is system B, if the system A is transmitting the data to system B, it will receive the data, and the data transmitting will be serial. One after the other, each and every bits will be transferred from system A to system B. That is what serial communication means. And there are only two wires here you can observe. One connection from transmitter to receiver, another connection from a transmitter pin to receiver pin. So your devices will be having two pins, one is transmitter and receiver pins, and one more pin will be connected to ground. So these are the three main pins available in UART communication. And the data follows from TXD pin of a transmitting UART to RXD pin of the receiving UART and vice versa. Means we need to transfer a data from A to B, we need to transfer from TXD, that is the transmitter line of A, to RXD of B. Similarly, from B to A, we need to communicate. We need to start from TXD to RXD. But there are three types of communication can happen here. One is simplex communication, next one is half duplex, and then full duplex. What do you mean by simplex communication? If a data is transferring from system A to system B, this kind of communication is happening, means it will be called as simplex communication. It is a one way of communication where A is trying to write on B, we can say. Next we have half duplex communication. Here half duplex communication says there are two ways of communication, but they are going to happen one after the other. You can see here, first system A is going to write on B and then system B is going to write on A. So this kind of communication will happen one after the other. This will be called as half duplex. And also there will be a possibility of full duplex communication also. Full duplex in the sense both the systems are going to transfer and receive the data simultaneously. Transferring the data also happening in system A and receiving the data is also happening in that system. That will be called as full duplex. How actually the transmission will be? Since it is a serial communication, serially the data has to be transferred from A to B. So it takes a packet system, means so whatever the data we need to transfer will be called as a data frame. This 5 to 9 data bits will be consisting of the data which is represented in binary ones and zeros, and this packet will be having a start bit. One start bit will be there at the starting and then followed by the data, and 0 to 1 parity bits. It can be 0 or 1, the parity bit is added, and then finally we will be having stop bits. This is what the packet format, where it will be having a data frame, start bit, stop bit and the parity bit. This will be transferred from A to B once the communication happens. Serially means first bit will be sent first and then the next bit and then the next bit. It takes how many number of bits there in the packet, that many time it is going to take to transfer the data. See, here you can observe the explanation. UART data transmission is an asynchronous form of serial data communication. Means the data is going to transfer serially. Here we are not going to use any clock signal to communicate from A to B. They are not synchronized also. So we are going to transmit a single data at a time. Right? After sending one bit, the next bit will be sent. This one bit, next bit and the next bit will be depending on the baud rate of the system. There will be a baud rate, there will be a setting between the system A as well as system B. These two systems has to be synchronized before transmitting the data. Depending on the baud rate, the system will understand the next bit is coming now. If serially 1111 is transmitting, the system has to understand the next bit after this 108 microseconds of delay if the baud rate is 9600. In this way, we are going to transmit the data from system A to B using UART. Let us understand this packet format, how actually the bits will be transferring in detail. So initially the data line will be having value 1. Here it is, you can observe there is no transferring happening now. So it will be in logic 1. That means there is no data is transferring. Once the packet is ready, we need to transfer. It will be bringing to 0, means start bit will be 0. Once it is going low, once this bit is transferred to system B, that will be understanding that I am getting a transfer or I am getting a data, it is started with 0. This bit will be just a start bit. Then we will be having word data, means 8 bit of data what we are supposed to send will be assigned over here. First LSB and then the next bits, finally MSB is going to be transferred, and parity bit can be added here. Parity bit is what if the even number of ones are there from D0 to D7, these are the data. This data consisting of combination of ones and zeros. If even number of ones are there, means this parity bit will go 0. If odd number of ones are there from D0 to D7, then this parity bit will be 1. So that indicating the receiver that if the parity bit whatever we are going to send from the transmitter is same at the receiver, then there is no corruption or the data flip occurs. If the parity bit we are going to send is not compared equally with the data at the receiver end, once the system B is going to calculate the parity, it gets the information that somewhere the data flip is occurred. We need to transfer the data again. That is what the case where the parity bit is going to be used to detect the error. And finally, there will be a stop bit by making the information to logic high. If 2 more cycles will be having logic 1, means the system will understand it is a stop bit after the parity. This is what the mechanism of UART data transfer. And then we will be having parallel interface. This parallel interface is used for communicating with peripheral devices in a microcontroller system or in embedded system. There will be a controller or microcontroller in an embedded system, and there are few peripherals we have connected. Let us assume a peripheral is ADC, analog to digital converter is a peripheral, an extra device which is connected with a microcontroller in an embedded system. These two devices want to communicate. In this case, we are going to call it as a parallel interface. Why? Because the data what we are going to transfer in between the microcontroller and a peripheral device will occur through a parallel interface. Means there are parallel lines here. This data bus is not a single line. how many bits of data we are going to transfer, those many number of data lines we can say, or it will be a standard one, 8 lines are there, so that we can transfer 8 bit of data at a time in one clock cycle from microcontroller to peripheral device. So here we will be having read and write signals, WR and RD. When WR is equal to 1, there will be a write thing happen. When RD is equal to 1, we are going to use that for read cycle. This WR and RD will not go high at a time. When WR is equal to 1, RD can be 1. When RD is equal to 1, WR can be 1. Means once write cycle is happening, there should not be read. Like that, the communication will be. And one more signal is there here in a parallel interface, that is called CS signal. That is chip select signal, or we say chip set signal. Why this signal is required means, if the microcontroller is trying to communicate with the peripheral interface, the microcontroller has to send the address bus to decoder. There will be an address decoder circuit. This address decoder circuit will say whether this address of the microcontroller's sending address will be this peripheral address. If it is so, it is making the CS pin of the ADC equal to 1. Means this CS pin will be activated by this decoder circuit depending on the address of the microcontroller. This microcontroller will be having series of addresses of the peripheral devices. This address corresponds to this peripheral device. So address decoder will decode that and select this device for the communication. When chip select pin goes high, then we can make the writing or reading operation in between these two. So here address bus and data bus are there. These two are parallel buses. So we will be having more than one lines, right? That is what A0 to AY-1 means. Suppose if it is a 8-bit address, we can say A0 to A7, there are 8 lines here in between these two. Similarly, if it is data is 8 bits, it will be having D0 to D7. There are 8 lines connected between ADC as well as a microcontroller. And this RD and WR will be controlled by this microcontroller itself, and CS pin will be enabled by address decoder circuit, that depending on which address the microcontroller is want to communicate with. This is parallel interface. And then we will be having one more protocol called USB. USB is Universal Serial Bus. This USB is a wired high-speed serial bus for a data communication. This is usually a wired one. Means here also we are going to use a serial bus, serial transfer of data for the communication purpose, that enables universal communication between the peripheral device as well as a host controller. This is what a tree structure you can observe here. This will be called as a star topology, followed by the USB. There are two hosts here, means it will be called as a USB host, or we call it as a hub. To this particular hub, where a device is acting as a host, we can connect 3 peripheral devices like this. Not only 3, it can connect up to 127. 3 peripheral devices and one more host is shown over here. If it is a master, we can connect the number of slaves like this. If it is a system, we can connect a USB other devices like 2 more devices like this. That is what it means. And each devices receives unique address from the host. These 3 devices are going to get unique address from the host here, and USB transmit the data in a packet format again. Since it is a serial bus and serial data transfer occurs, wherever the serial data transfer occurs, we need to transfer the data in packet format. As we seen in UART, there will be a packet format in USB also, and that packet format will be consisting of again a header, or it will be a starting bit and ending bit, that will be called as a trailer, and in between we will be having the data. And also error correction code requires a parity bit, that will be a packet format in USB also. And we may have some more information like some other bits also can be included with the packets. And this is what the pin configuration or the pin details of USB connector. It will be having 4 pins. One is V bus, which carries a power of 5 volts, and then D minus and D plus, this is with respect to the data is concerned, and then one more is the ground line. This is the general USB connector what we have seen in our systems. And the transfer of data will be occurred here in 4 different methods, or 4 types you can say. One is control transfer, bulk transfer, and then isochronous data transfer, and then interrupt transfer. So the generally control transfer, in the sense it is used by a USB system software to make a query, to configure the device and issue commands to the USB device. To pass this information, there will be a transfer called control transfer. Bulk transfer, in the sense it is used for sending bulk of data, means block of data we can say, to a device, where it supports error checking and correction also. For example, transferring data from PC to printer. When we are connecting a PC and a printer using an USB, the transfer will be bulk transfer. We are printing a huge data, so it will be called as bulk transfer. And then isochronous data transfer is used in real-time data communication between the two devices through USB. It doesn't support error checking. And retransmission of data in case of any transmission loss will be not there here in isochronous data transfer. And one more is interrupt transfer. When USB is connected to a device like a mouse or keyboard is connected to a system, this interrupt transfer will occur. Means there will be a small amount of data transfer between the mouse to the system or keyboard to the system. So interrupt transfer mechanism make use of polling technique to see whether USB device has any data to send or not. Means whenever we are going to click a mouse, it will be a single bit, means 1 or 0 like that. So it will be act as an interrupt, right? Whenever the data is transferring, in between, if you give the command, that will be act as an interrupt, then system will respond to that particular information. And there are different type A, type B, 3.0, USB mini, USB micro, USB type C and micro B. These are the different evaluations in USB, starting with type A. Generally nowadays we are using USB 3 and above system. And then we will be having Wi-Fi. As you know, Wi-Fi is a wireless high-speed internet connection technique which is going to be used to connect many devices like this to a router, right? There will be a router. Router will be a device which will be act as an access point. Generally it will be connected to a modem. This modem will be connected to a internet through a wire or wireless system. Once it is connected, so this router is able to connect many devices through wireless technique. And here we are going to use a radio waves to connect from router to the nearby devices. And this Wi-Fi connection established from the access point, Wi-Fi enabled devices within a specific range. There will be a range for the connection in between the router as well as the system which is to be connected to a internet. If we are not in the range, we will be not getting the Wi-Fi signals to connect. Generally these Wi-Fi standards the systems are going to work with a data speed and transmits on 2.4 gigahertz or up to 5 gigahertz frequency. This is what Wi-Fi is. And then GPRS. GPRS is General Packet Radio Service, which is the first packet based mobile data service which is given to the users. Mobile data service in the sense whatever we say internet today. So mobile data transfer service is GPRS is the first packet based mobile data service that is available to the users to get in mobile phones. That is what GPRS means. This GPRS comes into existence when 2G technology network is going to be used for the communication. So here MMS means multimedia messaging system is the feature which they have given once the mobile data communication through GPRS is established. And the maximum transfer rate is here 171.2 kbps. That is the very less transfer rate we can say compared to nowadays. And here the data can be assembled into original order at the receiving end. Means the packet based system it is, means the data will be transferred as a packets and it will be broken up into small pieces or small blocks, and that data will be transmitted over the various channels. At the receiver end we are going to reassemble it, and the mobile phone or the phone what we say will be receiving the data in a proper manner. That is what the method they have used in transmitting the multimedia messages within 2G networks. And here we can send videos, pictures or sound clips to each other just like text messages. That will be called as MMS. And GPRS also provide mobile handset the ability to surf the internet and dial-up speeds. You can also surf the internet, what we call it as browsing. And the limitation of GPRS is that data cannot be sent while a voice call is in process. When there is a voice call connected to a mobile phone to other device, other mobile phone, there will be no data transfer, or the data transfer is going to be break in that particular duration. This is what GPRS is. This is the first packet based mobile data service which is available to the mobile phone users. These are the few communication interfaces. Some are wireless and wired, and few are on board or off board. Thank you.